Yeah, huge honor to be here. This is a really cool conference. I'm super down with the whole functional programming thing, and I'm going to nerd out with you about it today. So, as stated, my name is Brian. I'm the co-founder of Begin.com. I'm an AWS serverless hero. I'm a maintainer of an open source project called OpenJS Architect, which is for building serverless apps. Used to work on a project called Apache Cordova, which you may know as PhoneGap. Sorry about that. Moving on. I'm blogging these days at a new domain. I just started doing this at webdev.rip. Check that out. And long-suffering Vancouver Canucks fan, so if you're a hockey fan, I want to talk about that later. I'm super into it. And the cat's name is Sutro. This has come up a few times already, so I thought I'd add it into the slide. So to me, functional programming reduces down to reliable and maintainable code. These are two sides of the same coin to me. And there's no real super rigorous definitions here, but to me, some of the principles that are important for functional programming are pure functions, immutability, higher order functions, and declarative formats. I'm not going to dig into this part too much, but I feel like this context will become important. So determinism means that we get the same result for the same input, or the same output for the same input every time. And this is so important and so often overlooked. It also means no side effects, but I've got a little asterisk there because there's kind of always side effects, isn't there? We do a good job of abstracting those away, but there's usually some side effects in a functional system. Immutability, values don't change. I want to be careful about that one too. That doesn't mean that there isn't any change in your system. It means that instead of changing values in place, we create new values derived from constants. There's a link, and actually this whole talk has lots of links, so at the end I collect them all up, and it's all online, so you can check those out later. Rich Hickey, you guys are probably familiar with him. He did this thing called Clojure. It's a pretty cool language. He has so many good talks, but one of my favorite talks of his is called Speculation, where he launches the spec system for Clojure. He talks about how there's two kinds of change. There's breaking changes, which we don't love. If you're a JavaScript developer, you're used to that. And then there's additive change, where we add new components to a system, and instead of breaking or changing old behavior, we're accruing new behavior. And so to me, immutability is a lot about that nice version of this. Higher order functions, these are just functions as values. So these are functions that take functions as arguments and functions that return functions as values. So, oh yeah, and declarative, so important. Expressing logic without describing the how. So what we want to do, not how we want it to be done. This contrasts strongly with imperative programming, where you have to tell step-by-step instructions, which is typically quite brittle. So I know you know this stuff, but these are really important bits to kind of set the stage for what we're gonna do here. So one of the big reasons that we like this stuff is it's more terse. There's just less code. There's less boilerplate. It's more modular. It's more reusable. It's easier to swap out functions with the same arguments than it is to deal with things that carry around their state like classes. I think this leads to better debugging and testing. And I also believe that this leads to easier to reason about concurrency, and so you can build faster, more parallel programs. So, anybody know who this guy is? Probably everybody here. This is a dude named John McCarthy. He famously created a thing called Lisp between 1956 and 1958, quite a long time ago. He sort of popularized the idea of functions as a first-class citizen inside the language. And I really wish it won, but it didn't. So functional programming in practice, we do have some cool newer languages that are kind of younger and have all the modern affordances that we're looking for. But typically we get Homer car languages. If you are a Simpsons fan, you might remember they asked Homer to design a car, and he went and he got everybody's feedback. And he incorporated everybody's feedback equally, and he ended up with this perfect illustration of what JavaScript has become. So functional programming. We've got pure functions, immutability, higher order functions, declarative, stuff you already all know. This just leads to more reliable, more maintainable code, which is great. Happy days. Let's get back to John. And check out that IBM 7000. That is the first computer to use transistors instead of vacuum tubes. And he's playing chess against it, which is awesome. And I love how there's like this sweet old clock and that dope tie. What a hero. So John, in 1961, proposed this idea of time sharing and utility computing. And this blew my fucking mind. So you could look at the snippets today from 1961 of this meeting he was at where he talks about computing as a public utility. And the part that just leapt out at me, this is 1961. There's no cloud. There's none of that yet. Each subscriber needs to only pay for the capacity he uses, but he has access to all the programming languages characteristics of a very large system. Like, how cool is that? 1961, he totally called it, like right away. The link for this article here, it's fascinating. It's only like 100 pages. It's super worth reading because he gets into debugging and replay and like all this stuff that basically is a roadmap for what we see as the cloud today. And you know, we got this idea and started really running with it in the 90s, but we had to wire up the planet first. Like there was a lot of cable that had to get thrown down. I started to research that and weirdly found out that we started doing it over 100 years ago for telegraph lines. So there's some cool stories about that. This is tangential, but it's so nerdy I thought I'd include it because it's kind of cool. Obviously, we're also starting to unwire the planet. We're adding satellites, and that's definitely a thing. So there's some gray beards in here. You guys remember what this was like. Back in the day, you'd be at the office, and you'd have a closet. It was never a room, but they'd call it the server room. It was hot. There was no window. There was all these like cables everywhere. Each one of these servers, totally incompatible with each other. All this architecture is completely different from each other, and you just sort of accrued all these beige boxes over time. That was obviously a really bad idea, and Amazon came around and said, hey, you know, utility compute, we can do that for you. And hosting providers and VM providers started becoming a thing. Typically, in that world, we were using an interface of some kind to provision infrastructure. Instead of going down to the store and buying a box and plugging it in manually, I went to a website and I clicked stuff manually. This became obviously an error-prone process. If you had two developers that had to provision infrastructure, one of them was going to screw it up at some point. So no to click ops. We got smart and we automated that stuff. This became known as configuration management. This person's playing with a synthesizer. This has nothing to do with the talk. It's just a cool picture. And you might remember these tools, but they were typically a little more imperative programming, or worse, you would have like a YAML file with bash in it, but you know, it worked. And then this also matured, and just to show you how far ahead Amazon is in all this stuff, check out that date. 2011, man. That's when CloudFormation started. There's actually evidence that it was 2009 in their source code. Then there's IBM Terraform. Ouch. And Azure's got a new thing called Bicep. It's kind of cool. Idea here is that you're using declarative formats to provision resources on the cloud. And so I roughly, and this isn't explicitly true, these are just sort of like vague-ish things, but configuration management is sort of more about like configuring stuff. And there's usually some imperative instructions embedded in declarative files. Infra as code is really about declarative formats and about embedding resources. And so to me, infra as code is just a professional practice, and this is very much a functional programming thing. It's all about immutable deployments. It's all about having deterministic outcomes, and it's all about using declarative formats and composition, so treating your resources like cattle instead of pets. Like when we had those servers, I worked at this company, and we named each server after mountains in Vancouver that we liked. And when the server died, we were sad. We're like, oh, Seymour. Like, you don't want that. These are junk. Your stuff, your system should be totally fungible. You should be able to throw all that away and not think about it. So the sort of next question comes, well, what is it? What do you mean precisely by infrastructure resources? So in a three-tier typical architecture, you've got a front end, you got a middle layer or a business logic layer of some kind, and a data access layer or a database layer of some kind. But we've been on the internet a while, and we know that traffic can come in spikes. It can be hard to predict, and we want to make sure availability is a thing. So we'll deploy that into 2 different regions just to top it off. This is a lot of moving parts. This is just a lot of stuff. And this is a completely reduced example. A real example would have hundreds of boxes and arrows. And so it's generous to say that this is getting complex. In 2014, Amazon rolls out this concept of cloud functions. And this is, to me, actually the first true example of utility compute that we've had since maybe the mainframe era. These are actually functions. They have inputs and outputs. They can be billed by the millisecond in some cases. And this isn't like a pitch about Amazon. I'm obviously a little bit AWS-centric, but the other clouds have these ideas, and a lot of these ideas will apply and can be used in these other places. So take my AWS-isms with a grain of salt. Another piece of this puzzle is persistence and state. If you're building anything that's somewhat, I don't want to sound like a gatekeeper and say real, but like anything that's doing like a business process or something that's like a little bit more serious, there's going to be a database involved for a bunch of reasons. And in most cases, you're going to want a cloud vendor to run that thing for you. You don't really want to run Postgres on an EC2 instance. You definitely don't want to run Postgres on a Kubernetes cluster. And in many cases, they'll take care of the scaling for you. And in some cases, they might even scale it down, which is nice. Amazon has a bunch of these. I think they have like over 10 databases, probably more. There's startups that offer this stuff. They have a range of trade-offs associated with them. But the state of the art is pretty good there. I'm personally a little more partial, and this is just a preference thing. This isn't like there's a technical reason, but I like the key value store, the document store, the wide column store approach a little more. I think that fits with web workloads a little more, and it fits with my mental model of programming a little better. You could throw Redis on here, or whatever they call it now, Valkey. Yeah. So yeah, these are all great choices. These are all awesome databases that will scale up and down. And when I say scale down, I mean like really, like you can put time to live on a row in DynamoDB or in S3. You can expire keys, and this is super useful. So you have a database that like can scale up to meet demand, but it can also scale down to save your wallet. So kind of interesting. These 3 components to me are building blocks. They're like little Legos. And we can assemble those Legos into full-on applications. Now, most applications today are still being built by load balancing monoliths, which is fine, but maybe inefficient. Maybe we're focusing on a lot more boxes and arrows than we need to be. Maybe we could just write code for our problem domain, deploy that, and watch it scale up and down on demand. And that's what the functional web app idea is. And it's using these 3 building blocks. This is not specific to any cloud vendor or any particular architecture. These are totally portable ideas. So why would you want to do that? Well, same reasons you want to functionally program today. You want to have these characteristics, and imagine if you could apply that back to your cloud infrastructure. There's a whole bunch of wins to be had here around all these things that we're already used to. Inevitably, when I talk to people about this stuff, they're like, ooh, at Lambda, will it scale? And the answer is, it depends. I'm a software developer. I can't give you a straight answer. But yes, it's going to scale. I don't know how many transactions per second DynamoDB is doing on Amazon.com on Black Friday, but it's way fucking more than you need. Isn't this stuff expensive, though? I heard a service is expensive. And the answer is it depends, but not really, not to me anyways. This beautiful, typical Amazon UI here is, so the free tier for DynamoDB gives you a gig of transfer in and out and 25 gigs of storage at rest, which is pretty good. Get your app going. But yeah, now there's going to be compute costs. How much is that going to cost? Well, they say that 25 gigs with a giga transfer is good for about 25 million requests per month. So if I did 25 million invocations of a Lambda function, and let's say they lasted 5 milliseconds, which is, generous, but whatever. Let's give them a little more RAM than they need. Let's give them 1152. And they don't need any storage, but you have it there if you need it. That'll cost $5. So, is that expensive? I guess it depends on how much you make. I'm not sure. I think it's pretty good to start, though. And I think you can get really, really far building your application. And if you're so lucky that Lambda and DynamoDB are too expensive for you, congratulations. You have a very high-class problem. Okay, but you know what? This is the finishing move everyone wants to bring out. What about lock-in? If I build my whole app on Cloudflare, what happens? And I don't have a good answer for that, because lock-in is not a thing you can avoid. If you deploy an EKS, I'm sorry, it's not going to work on Azure. It's just how it is. And so at a certain point, you have to accept that this is about trust, and you got to pick someone to trust. And Martin Fowler wrote a much better article than I can about this, where he talks about, don't get locked up in avoiding locking in. It's a good read. Now, this is absolutely fair. What about the learning curve? And, oh no, that I did not expect. Definitely not. I wonder. Is Amazon running Google Docs now? Oh, that's weird. Oh no, not there. Oh man. I see what the problem is. Okay, well, try this. There we go. This is what I get for using an AI-generated image, I guess. So what about the learning curve? If our archaeologists are to be believed, we've been harnessing fire for about 20,000 years, give or take. Sapiens have been around for about 1 million years. They were probably screwing around with fire before that, but we really got good at it about 20,000 years ago. So that's an amazing amount of time to not know how to make a fire and harness it. But it's still a little vague. What we do know for sure is 200 years ago-ish, we harnessed electricity. And we didn't do that because some property of physics changed. This wasn't like, oh, now we can use electricity. What changed was we asked some tough questions. We started asking tougher questions, and we started, experimenting. So progress isn't some inevitable thing that just happens. This requires us to think, and it requires conscientious work. It requires asking tough questions. So is there a learning curve? Absolutely. You're going to have to learn some new stuff. Is it worth it? I totally do think so. So this is the part that's going to be the most interesting with this mouse thing. I'm going to do a demo of what I'm talking about. And just, is that readable? Yeah. Okay, cool. All right, so I'm going. I could, but I don't know what that's going to do, so I'm not going to. Okay, so I created a new folder called LambdaConf. I'm going to use our open source project called Architect. It creates a CLI called Arc. Again, all of these concepts, totally portable. Please write your own. Don't use mine. Take these ideas and run with them. So I've got a little application here. It's got 2 parts to it. I'm declaring an API gateway that listens to get/, and I'm going to deploy that to West 2. And then I've got this index file with a pure function that returns an object that should look pretty familiar. It's just a bunch of HTML. So I've got 5 minutes. Let's deploy this. the first deploy is going to create a CloudFormation document based on that first little manifest file I showed you. We'll take a look at that in a second. And then it's going to deploy that CloudFormation document to AWS. If you've experienced CloudFormation, you're probably like, oh my God, he's only got 5 minutes. What's he going to do? But this is the serverless primitive, so this should complete within about 60 seconds. And subsequent deploys will be faster, because we're not deploying a whole bunch of stuff. We're just deploying a little tiny bit of code. Now, we'll take a look at that. And actually, why don't we run this locally? Ooh, local dev. What heresy is this? So sometimes people get a little bent out of shape about this. We built a local sandbox that emulates all the AWS serverless primitives. They're like, oh no, like, you're not supposed to do local dev with serverless. It's fine. You totally can. Amazon doesn't break their APIs. You can mock them. You can run them locally. You can put it up there. It's so fast, you probably don't need to. Like, as you can see, I've already deployed. So if I go here, and yeah, that was 55 seconds to deploy a pure function to the cloud that could scale up to whatever I probably want. But I don't have the wallet for that, so don't quote me on it. But yeah, so that's about as simple as it could possibly get. But let's add some more functions. Oops. Oh no. Look at me using Vim with a mouse like a weirdo. Okay, so let's add a post count. Whoops. And a post reset. And I'll run arc-init again. And if I jump over here, and I refresh you, you'll see I got 2 more functions. And so these will do what you think they'll do, but let's quickly bring in a library. This is just a helper to get rid of boilerplate. Remember earlier when we were talking about higher order functions? That's what that's all about. So we can just take all that nasty, and on our get index, we'll return some HTML. We'll have a form that posts to an endpoint called count using post. There'll be a button. Hi. And yeah, I'm just writing HTML in there like a savage. You can do it however you want. If you wanted to do a React or something like that, totally 100% legit, you can do that. Boilerplate. And yeah, I'm also using JavaScript, which is pretty gross. But the neat thing about Lambda is each one of these individual functions is a totally separate thing. So if I wanted to, I could prototype my app in JavaScript and then start moving individual functions into Rust or Python or Java or whatever I wanted, which is kind of nice. So for now, when I post, we'll just say where hi equals true or something like that. Let's just test this locally. So refresh. Oh, that's live. Oh no. Noob move. Forgot my helper library. We used to install this for you, and it's only like 50 kilobytes, but then people were mad. Like, I don't want you installing your stuff. And I'm like, I'm pretty sure you do, but we made it an opt-in. Okay, so now I gotta use my mouse. And you can see hi true. Oh, that's funny. Redirect to slash. We have a bug. I have to fix this or else it'll drive me insane. I realize I'm running low on time here. Okay, delete, hi, cool. Oh, no way. What did I do wrong? Oh, did I? Oh, I'm looking at my monitor, that's why. Look here. Success. Okay. If I was a faster typer, I would show you a lot more here, like interacting with databases, interacting with SQS, interacting with SNS, interacting with DynamoDB. I think you get the idea. You can do a whole bunch of little functions. Oh, but do let me show you this. This is kind of fun. So here's the app. If I do arc deploy dry run, it just did a quick deploy, but it didn't run it. All it did was generate the CloudFormation document. So this is our manifest file. This is like a format that we had invented, which people get bent out of shape about. So we also support YAML. If you have bad taste, you can use that. We also support package.json. You can use that if you like that. But at the end of the day, that little file turns into this. And yeah, that's 500. You would not write this file by hand. You would never debug this by hand. You would copy paste and accrue this by hand. But what you really want is to derive this from a higher level, more terse format, and then have it be a deterministic process that just treats this like a machine output. And so that's what's going on there. Okay. My startup is begin.com, and we deploy these things. We also do a higher level version of Architect called Enhance, which is a web component-based thing for people that like doing front-end development. Check them out. I think the best solution to a problem is to eliminate the conditions that created that problem rather than adding more solutions, which creates new, unique problems. It's a mouthful, but it's worth thinking about. I see a lot of developers today that think they can NPM install their way out of a problem, and that's just not the truth. I think we've got to do less stuff to get more out of our systems. And all the resources are here if you want to check it out, and I'll be around watching hockey probably later if you want to hang. Thanks, everybody.